Okay, so for number 4, it says the carbon tetrachloride reacts at high temperatures with oxygen to produce 2 toxic gases, phosgene and chlorine. So they give us the reaction here, and they give us the equilibrium constant. And the Kc means it's dependent on molar concentrations. So they give it to us, and it's 4.4 times 10 to the 9 at 1000 Kelvin. So it's asking us to calculate the equilibrium constant for this reaction. Okay, so we know that the way they got the this first equilibrium constant here is just by dividing the products by the reactants. So if we see the products here, we have COCl2, so it's going to be COCl2, we got times Cl2, that's the other product, Cl2, and then you divide that by the reactants, which is the compounds on this side. So that's concentration of this times O2. Now we're going to put the O2 to the power of 1/2, because as you can see in the reactant side, the coefficient is 1/2. So whenever there's a number in front of the element or the compound, you're going to raise it to that power. So whatever the coefficient is, that's going to be the power. So that's how they get the first equilibrium coefficient. We want to get this one. So one thing you already notice here is that on the product side, we have a coefficient of 2 and 2. So that should be kind of a giveaway, but we'll work it out anyways. So we're going to do the same thing. It's going to be the products over the reactants. Put that to the power of 2 because there's a coefficient of 2 in front of here. Same thing with this one. Over the reactants. So, as I said before, the only difference between this equation and this one is that has double the coefficient. So this one just said, it's implied there's a 1 in front of here. But with this one it's 2. So all you're going to do is get the this first constant and square that. So it's going to be 4.4 times 10 to the power of 9. And then you just square that. And that is going to give you 1.93 it's 10 to the 19. So that's going to be your answer. So really all you had to do was square the first equilibrium concentration, because we see that it was just doubled in the second reaction. So this would be your equilibrium constant for the reaction.